Very good morning, one and all. Today we are here to present deadlock conditions. Before going to deadlock, let's know what is deadlock. Comes to the definition. A deadlock is a situation in which two or more computer programs sharing the same resource are effectively prevented each other from accessing the resource, resulting in both the program ceasing to function indefinitely. So this situation is known as deadlock. Deadlock is a situation. Generally, for four reasons, a system will face deadlock. They are: first one, mutual exclusion; second one, no preemption; third one, hold and wait; fourth one is circular wait. Now come to mutual exclusion. The resources involved are in non-shareable mode. That means at least one resource thread must be held in a non-shareable mode. That is, only one process at a time claims exclusive control of the resource. If another process requests that resource, the requesting process must be delayed until the resource has been released. Now come to no preemption. A resource already allocated to a process cannot be preempted. That means resource cannot be removed from the process, are used to completion or released voluntarily by the process holding it. Next, come to hold and wait. Requesting process hold already resources while waiting for requesting resources. In the simplest way, there must exist a process that is holding a resource already allocated to it while waiting for additional resources that are currently being held by other process. Now come to circular wait condition. This is the last condition. The process in the system from a circular list of a chain where each process in the list is waiting for a resource held by the next process in the list. These four conditions leads to deadlock. Now come to resource allocation graph. Resource allocation graph stands for RAG. A resource allocation graph tracks which resource is held by which process and which process is waiting for a resource of a particular type. It is very useful and powerful and simple tool to illustrate how interacting process can lead to deadlock. That means resource allocation graph is a directed graph which contains set of vertices and set of edges, which show the state of the process, whether the state refers to whether it is in deadlock or not in deadlock. Now, processes are represented as a circle in which process name is written, and resources are represented in rectangles. If more than one resource exists, they are represented as dots inside the rectangle. Now, instance. Each resource contains some number of instances. Now comes to two types of edges are available. One is request edge, second one is assignment edge. If a process is using a resource, an arrow is drawn from the resource node to the process node. If the process is requesting the resource, an arrow is drawn from process node to resource node. Now comes to an example. Let us consider a system consisting of three processes and two resources. Let the process is P1, P2 and P3 and two resources R1 and R2. R1 resource contain one instance and R2 resource contain also one instance. Now by looking this figure here, look at the request edge and look at the assignment edge. Here, R1 resource is requested by the process P1. That means R1 resource is allocated to process P1. This is a requesting. And second one is P1 process request for the resource type R1. P1 process request one instance of resource type R1. This is an request edge and this is an assignment edge. Continue. Now, If the resource allocation graph contains cycle, then we will tell there may exist a deadlock. If resource allocation graph will not contain cycle, then it will not contain any deadlock. So this is all about resource allocation graph. The motto of the resource allocation graph is to check whether the system is in deadlock or not. Complete.